Hello, welcome to this discussion on the final exam solutions for the DSCA course. Now, what is DSCA course? This is offered in the first semester of RV University for the BTech computer science students. This basically talks about digital design, and we start with basics of electronics, diodes, and transistors. Prior to that, we what is being taught us the electric circuits, Kirchhoff's voltage laws, current law, and basic definitions of voltage, current, and power. Then we get on to the digital design part of it. Various flip flops and other digital design concepts are taught there. Then the final module of this course is about computer architecture. Basically, how does a CPU work? How does it access the instructions and execute inside? So basically, this is a course which introduces computer science engineers to the concept of how does a computer work, digital circuits, how they are built using transistors and diodes, and how does a CPU work. So this was a final examination question paper which was done in 2022, and we will discuss about the solutions for this. This is a 30 marks question for 2 hours. Now the first part A has 10 questions which carry 1 mark each. The first question is choose the option about the activities performed by a BIOS. Now what is BIOS? We'll come to that. When a computer is switched on, it performs power on self-test, runs the bootloader to bring the operating system, and then checks various components and peripherals connected to the computers. The fourth option is all the options are correct. So before we get into the answers for this BIOS, let us understand the sequence of operations happens when you switch on a computer. Now this is a laptop you have, and then you power on this. Then what happens is first is each laptop has a CPU. So the CPU has to be switched on, and it should be powered on. It should be reset to bring it to a known state where all the registers inside the CPU are brought into a known state. That's called the CPU booting up. Now once the CPU is on, it needs to access the instructions. So it cannot have instructions coming from the external RAM, which is normally not having a known state when the power is given to it. So basically they are built on DRAM, which is dynamic random access memories. So this is in terms of GB. This is called main memory. It is connected to the CPU also through some cache and other memory hierarchy, which we will cover it in the next course. Now when the CPU comes up, it needs to have instructions coming. So we normally have a ROM or a SSD, which is solid state device, which remembers what is being stored in them. Those instructions are being accessed. Now what does the ROM read-only memory has? It's having the program, which is a basic IO system, input output system. So this code is being run initially. After the CPU reset and comes up, it accesses these instructions and starts running. After this is run, which does the following actions. It actually does a self-test whether the RAM is okay and whether other peripherals like keyboard and mouse are connected to the CPU, which are all functioning properly, and what is the size of the ROM connected to the system. It could be 4 GB or 8 GB RAM based on your configuration. Then it runs bootloader, which is a bootloader code, which is the responsibility is whose responsibility is to bring up the OS bootloader. And once the bootloader come running, then it brings OS, which is normally stored in the hard disk or the solid state drives, which is of huge size and which is brought into the main memory. The OS is normally occupies a known space and it remains in that space throughout the program or throughout the laptop is running. Now once the OS is brought up, the control is given to the OS and then you get a login prompt on the screen. So this is a sequence of operation done when a computer comes up on power on. Now having seen that explanation, you know that BIOS does the following thing. It does a self test, and then it also brings up the bootloader to boot up the OS. Then it checks various components also. These are all the operations done not in the same sequence, but all of these operations are done in the BIOS. So the correct option is D for the first question. Now let us go into the K-map. Now this is also taught as a part of the digital design. Now K-map, as you are all aware, or if you go through the digital design course, you will know that there are variables A, B or C, D. They take different values which are given in this order while uh, grouping them into a K-map, which is gray code. Now we put each element, which is, now suppose if you say this particular cell is having a value 1, that means C and D are 0, that means C bar, D bar, C and D are 0, then C bar, D bar is 1, and then we have A and B bar. A is 1 and B is 0 internally. So this, if you put a 1 here, that means the product term of those AND of all these operations results in a 1. So this is sum of product terms. If you are grouping all the ones in a K-map, we are doing a sum of product terms. That means we do a AND operation and then we connect them all to a OR operation. Now this is the circuit we implement, and the K-map is for, Karnaugh map is for simplifying a given expression to construct a digital circuit. Now this is sum of terms and then there is a product of sums, POS form. In that case, what we do is we group all the zeros in the K-map and then form a product of sum term. Now product of sum means we have AND operation done after the sum operations are done. So we pick up these terms and then do it. Now the discussion is not about what is the purpose of K-map. Now it is to change the contents of the truth table of a given Boolean expression. It's not true because it is not changing any content. It is only to form a simplified Boolean expression. Now it is to simplify the given Boolean expression so that it can be implemented using minimum number of logic gates. Now why do we try to implement using minimum number of logic gates? Because as you put in more logic gates into the chip, it is going to occupy more space, if as well as the size of the chip will be more, as well as the power dissipated by the chip also will be more. So we want to implement a given expression, Boolean expression, with a minimum number of gates, and the K-map helps us in doing it. So the reason for doing it is that we want to simplify the circuit so that it occupies less space and consumes less power, so that you can build in circuits with more circuitry in it, consuming less power. So the B option is correct. Then what about C? It is to validate whether a given Boolean expression is valid or not. That's not the purpose of K-map. K-map is to, given an expression, we put it in the K-map and then we try to simplify it by grouping all the ones or zeros based on whether you want to build AND followed by or OR followed by AND. So the correct option is B. Now let us go into the Boolean expression. Choose the correct option about the Boolean expression. So this is the expression given, and then there are various options given. So before we go into the answers, we need to understand what are the variables, letters and terms. So let me open up this. Now variables are the individual elements or signals given to a Boolean circuits. In this case, if you see, it is A and B. So there are two variables, A and B. Now what are the literals? Literals are different forms of those variables. A and A bar are different literals. So there are A bar one literal, and A is another literal, and B is another literal. So this expression has three literals. And then what are the terms? Terms are, a term is an expression formed by literals, of course A bar and A or B, and operations at one level. Now this A dot B is an AND operation, this plus is OR operation. So A dot B is one operation done at one level, then we perform a AND operation. So there are one operation A, B, and then A bar is applying a complement on A. So that's another operation. So there are two terms grouped together with an AND operation, which is an OR operation. So there are two terms in this expression. So once you understand the definitions of this, it is very obvious here that there are A, B, C, D. There are four terms in it. So all the variables are four, sorry, not terms, four variables. There are four variables in it. Fine. Now, how many literals are there? individually we need to consider A bar as one literal, B bar as D bar as another literal. So 1, 2, 3, 4, 5, 6, 7. 7 literals are there. So that's this is true. Then there are other things are wrong anyway, but terms are three because this is one level we do AND operation, another level, and this is another. So all of them are given as three, so there is nothing to choose from. So once you identify that there are 7 literals and terms are three, B option is the correct option. Okay, now we want to look at this particular circuit, and you can understand that this is a NOT gate, OR gate, and AND gate. In this circuit, if AB is given as 0, 0, now two variable signals are given. If they are given as both are 0, 0, and then we give a 1, 1, what is the output? And we are giving it in one after the other. That means if I give a 0, 0 as an input, whether the output is 0 or 1 or 0, and if I give 1, 1, whether it is output is this. So we have to choose one of them. For this, we need to go through this circuit and then understand it better. So let us do that. Now, if I give 0, 0, let us give 0 here. Now, this is a not operation, so this will be 1. And then this will be 0 here. The same signal is coming here. And B also we are giving it 0, 0. So, we are assuming AB is given as 0, 0. Now, R both inputs are 0, then it will be 0. So, you get a 0 here. Now, when you give 1 and 0, the output will be 0. So, you get 0, output is 0 here. So, when I give AB as 0, output is 0. Now let me change the color to give another input. AB as 1, 1. Now what is the value of Z? So let us give 1, 1 here. Now this will also be 1. Not of operation, 1 is 0. Now 1, 1 is given to R, so this will be 1. So 0 and 1 is given, and AND gate will always give you 0 unless it is both are 1 and is not going to give you 1. That is 0, whereas OR operation has given us 1. Now 0 and 1 is given, then we get an output 1. So this is 1. Now if it is AB is 0, 0, output is 0, and AB is 1, 1, output is 1. Now let us look at the options we have. AB as 0, Z is 0, yes, and then when ABB is 1, this is 1. So option A is the correct one. Now what is this circuit? Choose the correct statement about SR latch. Now let us understand about the latch first. Now one thing we need to know that this is the signal and they are all given as not a prime, it's R and S. That means that this is the active high circuit. Okay, active high. That means if I give a 1, it takes some action. That means it does a reset operation if I give 1, not when I give 0. That's what it says based on the signal. But let us see if I give this as 1. Suppose I want to reset it. If I want to reset it, I will not give this as set operation because I can't give the same command, or I can't give reset command as well as set command to the given circuit because I need to give one of them as a valid command. So I give reset command. Now what happens? R is always 1 here, so this will give you a 0 output. Now that 0 comes here. If two inputs are 0 to the OR gate, it is going to give me 1. That means Q is reset to 0 and Q bar is nothing but a complement of that, that is 1. So that's what happens when I give 0, 1 and 0. Now let me say if I am changing the command, I want to set it as 1. That means I want Q to be 1 when I give a set command, and it happens to be S signal, so that is active high signal. That means I need to give 1 to make it perform an operation that I am interested in. I want to set a 1 to the Q output. Now when I give a set as 1 here, suppose, what happens? Immediately you need to find out the final steady state output. So even whatever may be the intermediate state, if I give a 1 here, earlier it was 1, but if I immediately give a 1, the OR is going to give me 1, and then the final output because of NOT will be 0. So I finally get a 0 output here. So that's a steady state. Now this is 0, and it's anyway I am going to give a 0. So output will be 1 here. That means I am making the Q as 1 by setting it to the command. So Q bar will be a complement of that, it becomes 0. So that's what happens when I give a value of 1 here and then reset value of 0 there. So that's how the valid command. If I give, what if I do 0 0, both, I am not giving any command. So let us see whether if I give 0 0 what happens. So let me choose another color. Now I am keeping all the old ones to make you remember that, maybe to not to confuse you. Let us erase everything. Now suppose if I give both zeros and assume that earlier this is 1 and then I have a value 0 there. Now I make it both 0 0. What happens? Now this 1 is already here and I am giving a 0. So R is 1 here, output is 0. So it remains as 0. Now this 0 comes here and output of R get is 0. This will be 1. So it will retain the value of previous one if I give 0 0. That means no command is given. I want to store the previous, retain the previous value which was there. Now I assume that previously it was 1 and 0. If I assume that previously what is stored in this cell is the other way around, what happens? Let me give an example of that also. Suppose if I give, it was Q bar was 0 and Q was earlier 0. Now Q bar was 1. Now this one will be here and the 0 will be here. Now 0 0 if I give, it will be output is 0 and this will remain as 1. Now 0 1 is there, so output will be 1 and not of that will be 0. So it will keep the old value. If I give the set as 0 and offset as 0 and previous values were the other way around. So that means that I can retain the old value, and the reset command and set command being 0 means it has no impact on the previous state of the switch latch. It is called a latch. So that is what happens. Now the other input which could be given is or both are 1. Now let me talk about that now. Suppose if I give, let me erase all, okay, let me erase everything to make it clear to you. Now suppose the previous state was 0 here and 1 there, and I give both are 1. Now actually this is a contradicting input. I want to set as well as I want to reset. Then the state of this is not consistent because I want to say that Q has to be set. If I am saying this is 1, I want this to be 1. But if I am saying that reset is 1, then I want Q to be 0. You know, Q value cannot be a 0 as well as 1 at the same time, which is a confusing input. I can't say that please stand up. At the same time, I cannot tell you that please sit down, which is contradicting my commands. I cannot contradict my own commands, and then you will not know what to do in that case. So similarly, the circuit will not be in a known state if I give this input. So it depends on the previous state, and then it may do any one of this command, and it is forbidden. This input is forbidden. So now let us go back to the question here. SR latch. This is called SR latch because S and R signals are given. The forbidden state can be defined as Q and Q bar values being the same. So what will happen is if I give that kind of input, it will result into Q and Q bar being the same. So let us check that out once I give both command as 1. Suppose if I give both as 1, what happens? This output will be 1, correct? Because R is 1. So this will be 0. Now this is 0 doesn't mean that the output will be different because R will always be given 1 and this is 0. Now what happens is if I give both 1, I get whatever may be the previous value, I get both Q and Q bar as 0. Now when I say Q and Q bar, that means they should be complement of each other. They can't be same value, which happens to be contradicting my own circuit. So this input is also forbidden. Okay. So this explains that this is valid, the forbidden state is both are same. Q and Q bar values are complement of each other during its normal operation, which I explained to you. Either it can be a set command or reset command, which is a valid operation. Then Q and Q bar will be complement of each other. This is an active high secure because the command is given when I give 1 1. So all the options are correct. That's the correct answer. Now let us look at some other latch, which is S bar and R prime. That means I'm giving a complement as a command. Now I will explain one set of command to this, and then other one I leave it to a homework for you to try it out. Now suppose if I say a 0 here and 1 there. Now command is actually a 0 because it's a active low circuit. Now remember, if I have a prime here, that means actual signal given to the circuit is when it is low. So this is 0 means I am setting this output as 0 1. Now let us see whether it happens or not. Now suppose if AND input, one of the input is 0, you are sure to get a 0 at the output of AND, and then a 1 here. It's going to be certainly 1. Now once this is 1, I have a 1 here. 1 1 will always be, and output will be 1, and this will be 0. So Q is set to 1. That means when I give a S prime, I am setting it Q to 1 and Q bar to 0, which is a complement of that, and it's a valid state. Now what if I do another signal? Okay, let me say I want to now make R prime as 0 and S prime as 1. Now I want to make the Q as equal to 0. Even if previous value is something else, I want to do that. Now once I have a 0 here, okay, a 0 here, okay, whatever may be the other input, 0 or 1, I am going to make this as a 0. I'm sorry, I'm confusing you. This is reset is 0, so this is going to be 0. Okay, this, let me erase everything so that it's very clear to you. Now let us assume that we are giving a 0 here and a 1 here. Okay, I'm giving reset command as 0 and set command as 1. That means no command. That means reset should happen. So AND gate output is 0. So this will be 1. Now 1, this is 1. This is going to be 1, and output of AND will be 0 and 1, and then this will be 0. That means I am successfully made Q as 0 and Q bar as 1, which is complement of each other, and this is steady state, and this is a valid input. So this command is active low, and it sets basically the value of 0 and 1. In that case, what is forbidden? Both being 1 is forbidden, because I can't give no, both being 0 is a forbidden command, because I am saying that set as well as reset to be 0, which is a command which is forbidden. Okay, so this circuit, if it is given, and you need to look at what happens during that time and then understand it better. Okay, so to summarize, let me summarize them. This is active high circuit. Let me change the color. So this is active high circuit because R and S are 1, then a respective command is taken. If reset is 1, this will be set to 1, reset to 0, and if it is set is 1, the Q will be set to 1. And if I am saying no command means I give both as 0 0, then previous state is maintained, and I cannot give both as 1 1 because I am contradicting my own input. Both I am making it reset as well as to set, which is forbidden, and both will be not be complement of each other. So that's a forbidden state. Now exactly reverse happens here. This is an active low circuit, whether this is active high circuit, this is active low circuit. Command is S prime is 0 and R prime is also a command is given. 0 means is a forbidden state. I need to give either one of them as a valid command. Here I am giving set command, then Q will be set. And if I am saying this as 1 and this as a 0, that I want to set it to Q as 0, then output will be 0 and this will be 1. So this is a complement of each other. So these are the different states of this particular circuit. Now let us look at the question here. This is SR latch. You know that R and S are no primes are there, so it's an active high circuit. It says this is an active high, so this is a valid statement. And then forbidden state is both Q and Q bar being the same, which is forbidden because it should be complement of each other. So this statement is also correct. And then Q and Q bar values are complement of each other during the normal operation, which is also a valid statement. So all the above options are given, which are correct. Now let us look at this circuit now. It says some of the inputs. So let me first explain the circuit first before we go into the details. Now, what is FA? FA is a full adder, which is already given. Now, a sub signal is given. If the sub signal in the circuit is high, that means I am giving this as a 1. High means 1. Now, why am I saying this is a full adder? Because there are 3 inputs coming to the circuit. Okay. This is a full adder, that means off adder adds 2 inputs, where the full adder adds 3 inputs. Now, if I give an input like this, 3 inputs are given, all zeros, then output is 0, and then there is a carry. There are two outputs coming from the circuit. One is the sum operation, this is sum operation, and then a carry which is going to the next level. So, if I give all zeros, carry will be 0 and the sum will be 0. What if I give like this? Now, what happens is when I am doing this, this is I'm actually adding 1 and 1, it should be 2. So, carry will be 1 and the sum value will be 0. So, it is effectively 1 0, which is a value of 2. Now, what if I give all 3 inputs as 1? Then actually I am adding 3 ones, that means it should be 3. So, some value will be 1, carry will also be 1. So, we will get a 1 1, which is 3. So, full adder basically does 3 of binary inputs are added. Okay, that's what is the basic internal operation of a full adder. Now, what is the purpose of this sub? If you look at the full adder, actually it is adding a 2 numbers. Suppose how many bits are getting added? It's adding A0, A1, A2, A3, and then B0, B1, B2, B3. So it is adding 4 bits and then it gets a value, it's a sum value, okay, D0, D1, D2 and D3, and then there is a carry coming, which is a C4, because the fourth bit is actually it's a fifth bit in this as a carry. Suppose if I am not able to add, which can be expressed in a 4-bit pattern, then you get a carry out coming out from this circuit. So now whether I am doing a full addition operation or a subtraction operation is decided by this particular signal. Now imagine this happens to be a 0. That means the subtract signal is 0. So you will get a 0 here everywhere. And then we are having B signal coming inside, whatever may be the signal. Now, what is this gate? This is a XOR gate. Now, what is the truth table of XOR? If I give 0 0, XOR will be, output will be 0. But if one of them is different, I get output as 1. And if they are same, I get a 0. So, if a same inputs are given, it gives a output as 0. If two different inputs are given, it gives me 1. So, in that case, if I have a 0 here, what will happen? If I give a 0 here, then it's a 0 0, so output is 0, it comes as a 0. Now, what if I give a 1 there? Suppose if I am giving a 1 here, I get a 1 here, right? Because already one input is given as 0, the other input can be a 0 or 1 based on the number that you are feeding, especially the B input. Whatever value you are giving, based on that, the other input changes. So, one value is decided as 0, other one is 1, then I get a 1 here. That means, if I make this sub as a 0, whatever is a B, it comes as it is. Okay, that means I am not changing anything if I am giving subtract as a 0. Now, let me give an example where I give subtract signal as 1. Now suppose subtract signal is given as 1. So let me take this, okay. I am giving a 1 here, okay. Let me assume that the signal is everywhere, but because we have already analyzed it with a 0 input, I am going to take this two gates to understand if I give 1 what happens. Suppose B2 was 0 and B3 was 1. If I am giving a other input as 1, it is a different input, right? 1 and 0. So this will make it as 1. Here 1 1 is there, which is same input, so it will make this as a 0. That means as far as the input is concerned, I am getting a complement value if I make the subtract signal as 1. That means if I say subtract as 1, I am going to get a complement of each of these bits there. Now, apart from that, I also get a carry in input. The three inputs I talked about for adding, I'm going to give a 1 here. That means I'm complementing the bit and then adding a 1 to the B, and then I'm going to do a addition. That means if you recall, a signed arithmetic is performed by 2's complement rotation, okay, performing 2's complement.